This is the second part of the video, which presents the example model for SlopeX. As I said in the introduction, I'm using Rhino for this stage, but any mining or CAD package can be used. So, just to show you the model, I'll turn these layers on and off as I go, but this is the fictitious pit, so I'll turn off these layers here. And this is the area of interest, where we will have a higher density mesh. Where's it gone? There we go. And this is stage 2 here, which is a backfill or buttress area. As you can see here around the edge, the mesh itself doesn't intersect stage 1, but this is okay, and this really is where the power of the meshing tool comes into its own. I'll put the topography on as well. As you can see here now, this also doesn't intersect. So it's important here now, you do not have to spend time making everything conformable as you would normally have to in other 3D packages. Okay, let's start with exporting the topography. So I've created a folder here just on the root of the C for example model, and let's call this topo. I'm going to use the STL format here. It doesn't matter whether you use ASCII or binary. Okay, next is the stage 1, which in this case is the main pit. Importantly, this can be a survey pickup or an updated area where extraction has occurred. So I'm just going to export this now again. Stage 1. Same for stage 2. The area of interest, which in this case I'll just call AOI. And the faults are here, but what I've done is I've actually trimmed them to the pit. So if I turn off my original layer, there we go, you can see I've trimmed them to a distance from the pit to avoid unnecessary zones. So let's export these. Okay, you can see that all the files are now in the directory along with the SlopeX license file. So now we're ready to use the graphical user interface.